Hi everyone, I'm going to be looking at rationalising the denominator today. So this is the second video on Surds. So this is aimed at GCSE, typically the higher tier stuff. So here we go. Okay, so rationalising the denominator means writing the number whereby the denominator is not a surd. So for example, if we had 1 over root 2 and you type this into your calculator, it would come out with the following. Okay, so it will give the answer as an equivalent fraction without having any surds in the denominator. There's no surds at the bottom. So the reason we do this is mathematically we don't like to say I'm dividing by an irrational number. I don't like expressing a number as something divided by another number that I can't even really write the end of because it just goes on forever. So what we do instead is we say it's half of an irrational number, or it's some fraction of an irrational number. So we give it as an equivalent fraction with no surds in the denominator. So the way we actually go about doing this is what I've basically done here is I've gone 1 over root 2, and if I times by root 2 over root 2, I'm actually not changing it, I'm making it an equivalent fraction. This is just the same as timesing by 1 in a clever way, okay? So I'm timesing it by root 2 over root 2, I'm just scaling it to an equivalent fraction. Just like having a half, I'm writing it as 5 over 10. I'm scaling it, but it's the same fraction. I get 1 times root 2, which is root 2, over root 2 times root 2, root 2 over 2. Okay, so this is rationalised. I've rationalised the denominator. It's not a surd anymore. Okay, another example. If I have 2 over root 3, I'm going to multiply by root 3 over root 3. And on the top, I get 2 root 3 over root 3 times root 3, which is just 3. So if you type this into your calculator, it will tell you it's equal to this. Okay, the top can be as messy as you like. The top can have loads of surds in it, horrible looking, but as long as it's divided by a whole number, an integer value, then we've rationalised the denominator. Cool, right, some trickier examples. If I now have 2 over 1 plus root 3, the problem with this is if I go, okay, I'll times by root 3 over root 3, let's look what happens. I've still got a surd on the denominator, and I can't sort of cancel like this because it's an addition, so that doesn't work. So it ends up being like this, and this is not rationalised. I've actually, if anything, made it worse. So we can't do that same technique when there is an addition or a subtraction. I can't just times by root 3 over root 3. Now this trick comes back to a bit of algebra, a bit of quadratics, double brackets. Basically, I'm going to make it like a difference of 2 squares. I'm going to change that from a plus to a minus, and let's look what happens. So on the top, I get 2 lots of 1 minus root 3. I'll deal with that in a minute, or I could leave it like that, it's fine. And on the bottom, I've got a double bracket expansion. So let's expand that out. This times this is 1, 1 times 1, 1 times minus root 3 times positive 1 is plus root 3, and root 3 times minus root 3 is minus 3. This and this will cancel each other out, plus root 3 minus root 3, and end up with 1 minus 3, which equals minus 2. Okay, and that will actually cancel that to make minus 1, lot of 1 minus root 3. And if you want, you could expand that out. Minus 1 times 1 is minus 1, minus 1 times minus root 3 is plus root 3. And that would be what your calculator tells you the answer to this is. Okay, and that's not obvious from the start. Cool. Go back and look at the first one, just a reminder from last time, root 48, if you split that as a square root of a product, where we take the biggest factor that we can think of that's a square number that goes into it. So 16. Right, I'm going to do another quick example here, and let's rationalise the denominator for this one. There's a common factor of 3 that ends up in 2 root 3. I have 6 root 3 divided by 3. 6 lots of something divided by 3 is 2 lots of that something. This is a good one to look at, x over root x. And if we think about it, a number divided by its square root should equal its square root, because that's what we're doing. A number square rooted, the value it should give is the other square root. So square root of 25 is 5, 5 times 5 is 25. So x divided by root x is root x. Point is, 2 numbers that times themselves to make x. So even going through that process, we can sense check it. Okay, I'll do one final one. Let's do this one here, show that. Sometimes by 1 in a clever way. 2 lots of double bracket expansions. So 5 times 2, so we've got 10, 5 times minus root 3, minus 5 root 3 on the top, plus 2 root 3 times 2, 4 root 3, 2 root 3 times minus root 3 is minus 2 times 3, which is minus 6, all over 2 times 2, so 4, 2 times minus root 3, minus 2 root 3, root 3 times 2 plus 2 root 3, plus root 3 times minus root 3 is minus 3. Let's tidy this up. On the top, 10 minus 6 is 4, minus 5 root 3 plus 4 root 3 is minus 1 lot of root 3. All over 4 minus 3 is 1. That cancels with that. That's the same as 4 minus root 3. And is that what they wanted us to show? Yes. So we've done it. Cool. So there's some other questions there you can try on that topic. Some really good free resources online. Again, so don't feel the need to be purchasing certain textbooks or worrying that you can't do any maths, because there's plenty online. Okay, well done with that, and keep checking for more videos soon.